All right, on to the final example here. So in the previous example, we talked about the three conditions being met. So when you look at a question, you got to ask yourself, are we dealing with a success or failure? So in this case, we're looking at a pop company, checking to see whether it's 42% market share seems reasonable. So I mean, if they like the drink or they don't, there's your success or failure. If person A says they like the drink and person B says they don't, person A's results didn't influence person B because it comes down to personal taste, so the events are independent, and the events are identical, or the trials are identical, because no matter, you're just taking a drink from the same bottle, so it has to be the exact same. So it qualifies for a binomial distribution. What makes you look at whether it's a normal distribution or not is this right here, this fact right here, 25 people. When I want to, if I have to do a whole bunch of calculations, you start asking yourself, is there a shortcut? Because binomial distribution, you'd have to do 1, 2, 3, 4, and so on and so forth. Here, I'm asking myself, is this a normal distribution? So is it a normal distribution? And that's the question I'm going to ask myself. Well, we have our tests, so n times p. So we're looking at 70 people, and success is the 42% market share this company believes they have. So we look at the 70 times 0.42, which gives us 29.4, which is greater than 5. So that passes the test. N times failure, so 70 multiplied by the 0.58. And we know that's going to be the case, but we'll double check it, and we get 40.6, which is greater than 5. So that passes. So our mean is equal to n times p. So that's the 29.4. And our sigma is equal to the square root of n times p times q. So 70.42.58. So when you do that calculation, we get a standard deviation of 4.1. So that means, therefore, we're going to assume, oh, not awesome, assume our data is normally distributed with a mean of 29.4 and a standard deviation of 4.1. So now we can go ahead and we can answer question A using a normal distribution. So the first one, determine the probability that fewer than 25 people will choose the drink. So the probability that fewer than 25 people will choose the drink. Remember, we're dealing with discrete data, okay? People, that's discrete. You can't have part of a person. So when you use a normal distribution, you have to adjust this statement and you extend it to 25.5. All right, and it's because you got to give each value, the 25, a value or an area. So 25 actually extends from 24.5 to 25.5. So again, visually, and I'll exaggerate it. If this is 24, to give it area, we move a half this way, a half this way, so that 24 is actually the area of that rectangle. All right. Now, the z-score information calculates area less than that, so we can go straight to a z-score. So now we're really looking for a z-score that will be less than, yeah, 29.4 divided by 4.1. We're looking at negative 0.95. And going to the z-score table, negative 0.95. Oops, I think my negatives are up here. So there's my negative 0.9, 0, 1, 2, 3, 4, and 5, 1736. 0.1736. So therefore, the probability of less than 25 people choosing their drink or their cola is 17%. So there's 17% of a chance that less than 25 people pick it. And B part, determine the probability that exactly 40 people choose that drink. So if it's exactly 40, and again, this is the tough or the more challenging one. Remember that you got to do it in terms of the area of that corresponding rectangle. So again, at 40, if this is 40, we have to give that rectangle some area. So we go to 40.5 and 39.5. So we're looking for this area right here, which will be found by finding the area for x less than 40.5 and subtracting the area for x less than 39.5. So that whole area conversation again. So it would be green, subtract red, gives me blue. So I'm taking the bigger area and subtracting the smaller area. Once that's done, we change both of those into a z-score notation. So the 40.5, and I need the mean minus the 29.4 divided by 4.1. So less than 2.7 and 2.71. Go to two decimal places. And 39.5 minus the 29.4 divided by 4.1 again. And we get 2.46. So now we go to our z-score table and find both of those corresponding values. So 2.71, 2.701, so 9966, 9966, and 2.46, 2.401234, so that's 9931. 0.9931. So if exactly 40 people are going to enjoy this drink, the probability of that occurring is very, very slim. If I look at it, I get 0.0035. So therefore, the probability exactly 40 people enjoy the cola would be 0.35%. So very, very small chance that exactly 40 people would enjoy it. All right. If you have any questions with the homework, you know where you can find me. And good luck completing the task, and make sure you attempt to apply it to your project.